So in the last lesson, we dealt with a lot of different data samples that had a distribution to them. Some of them had a different mean, some had a different standard deviation, and we ended up finding that most of the data usually revolves around the center or the mean of the data, and less of it as we go one standard deviation away, even less as we go two standard deviations away, and it seems like almost none of the data, but occasionally some of it, is more than 3 standard deviations away. So eventually what we have is all of these situations taking place where you're accumulating data over time, and we end up with this thing called a bell curve, and we have what's called a normal distribution. So what a normal distribution is when you take all the data and you distribute it across this bell-shaped curve, right? You've probably heard of a bell curve before. So you're going to take all the data and you're going to dump it onto this bell curve. And it just approximates where most of the data usually is in the distribution and populates the rest of the distribution as well. So I'll just upload an image of a bell curve here. Now you guys have this on a separate sheet of paper, so I'm going to give you each a full-sized bell curve that you can have. It's just a sheet of paper that we'll be referencing pretty frequently. But this is the normal curve, all right? So it only works when you're dealing with increments of half or 1 standard deviation. Obviously, there are bell curves out there that will go by 0.1, right, or 0.01, but really, we're not even going to care so much about the 0.5 increments so often. It's really just 1 standard deviation, 2 standard deviations, 3 standard deviations, and so on. So what it's explaining here is what percent of the population falls within these ranges on a normal distribution curve. So one thing I notice is that between 0 and 1, I have this 19.1% and then again this 15% of my data, which would come out to be 34.1% of my data in this range. So what it's saying is if we have a population that's normally distributed, 34.1% of our data would be within this range, would be between the mean and 1 standard deviation above the mean. All right, so we're going to kind of analyze this today. What percent of the population is within 1 standard deviation of the mean? Well, we just talked about how above is 34.1, right? If I do 19.1 plus 15, that gives me 34.1. But that's only above. We also have this space below, right? It says within 1. It doesn't say which direction. So 1 above and 1 below. That would also be 34.1. So 34.1 times 2 would equal 68.2. So 68.2% of my data falls within 1 standard deviation, which is consistent with what we found in yesterday's notes, right? Most of our data, that's the vast majority, most of the data is right here. Way more than half, 68.2%, that's most of the data. What percent of the population is within 3 standard deviations? Well, we've got some options here. We know that this is 68.2. So I could add to that my 9.2 and my 4.4, and then another 9.2 and 4.4. Or, what I think is easier in this situation is, I know that 100% of my data is this whole thing. So I'll take away 1.7, I'll take away the 0.5, I'll take away the 0.1. All right, so I have 100 minus 1.7 plus 0.5 is 2.2. So all that adds up to 2.3. And remember, I also have that on this end too. So I have 1.7 plus 0.5, that's 2.2, 2.3. So I have 2 of these. So 100 minus 2 times 2.3 is going to be 100 minus 4.6, which leaves us with 95.4% of our data. So almost all of our data falls within this range. And again, that's consistent with yesterday's notes. Almost all of our data is within 2 standard deviations. Within 3 standard deviations, we've got almost all of it. It's really just this 0.1 out here and the 0.1 out here that are not within that range. So that would be 99.8% of our data. Almost all the data. And lastly, what percent of the population is outside of 3 standard deviations? So these are our extreme outliers, 0.2%. These are the people that are crazy tall in a given sample, or that weigh almost nothing if we're comparing weights of people, or test scores where someone got a 0 or 102 because of extra credit. So these are your outliers that really are just not consistent with the rest of the population. So now let's use our analysis of the bell curve in general and apply it to some problems where we might use a bell curve. At Williamsburg Charter High School, a sample of 600 students' STAR exam scores were normally distributed. So that statement is there to let you know that when you compare these scores, you're using the normal distribution bell curve. You're using this standard bell curve. If the mean score was 860 with a standard deviation of 40 points, all right, so what I'm going to do is I'm just going to label right here, that's an 860, and then every one standard deviation away from that is another 40 points, right? So this is going to be my 900. This is going to be my 940. This would be a 980. And in the other direction, I'm going to subtract 40. So 820. All right. What percent of student scores fell within a range of 820 to 900? So now that we've labeled the bell curve and we're actually talking about real scores, we've got 820, which is one standard deviation below the mean, and 900, which is one standard deviation above the mean. So in that range, we're dealing with 68.2% of the data, right? Just like above, because we're talking about all the scores essentially that are within one standard deviation of the mean. It's just like this problem right here. What percent of the students scored above a 900? So now we're talking about one standard deviation above the mean and everything above that. So we're going to add up our 9.2, our 4.4, our 1.7, our 0.5, and our 0.1. Or what I think would be a little bit easier is I know that this is 50% of my data. So there's 50% plus 34.1. And that's going to be all of the percent that's not included in that, right? So I have 50% of my data, plus another 34.1%, and I'll write it out here. 50 plus 34.1 is going to give me 84.1% of my data. But those are the opposite, right? I want the ones that scored above, not below. So I'll just do 100 minus 84.1. which gives me 15.9%. So that's how many students scored above a 900 here. And if you put that into context, you figure that that score 900 is one standard deviation above the mean. So it's above average. So these are all the people that scored above one standard deviation above the average. Not a lot of students. It's a small number of students. Next one is where we start getting into actual numbers here of people. Lionel scored 940 on his exam. So Lionel is 2 standard deviations above the mean. Lionel's doing very well. How many students scored better than Lionel? So that's not saying what percent of students scored better than Lionel. That's saying how many. So here's what I want to know first. What percent of students scored better than Lionel? Well, that's going to be 1.7 plus 0.5 plus 0.1. Okay, so that's 2.3%, right? 2.3% of students scored better than Lionel. So what is 2.3% of 600 students? Well, we'll do 600 times 0.023, and that gives us 13.8 students, which doesn't make sense because we need people, and you can't have 0.8 people. So when we're talking about a normal distribution, when we're talking about statistics and probability, it's all estimate. It's a really good estimate. So what this is a very, very accurate estimate of how many students probably scored above Lionel in this particular sample. I'm not going to say 13.8. I'm going to say the number that is closest to the number we got that makes any sense at all, right? I'm not going to say 13 because 14 is a much closer number to the exact number I got. So I would say approximately 14 students. All right, so in our practice, get used to making sure you're giving an answer that makes sense. If we're talking about people, again, we can't have part of a person, but we are going to be rounding to the nearest whole number because we're not necessarily saying that there can't be numbers less than that. We could be talking about more than 13.8 people. It doesn't have to be 13, okay? So round just like you've always rounded with these. All right, guys, that's it for tonight. I'll see you guys on Monday.